Hi students, so let us continue with the topic all pair shortest path algorithm. So in the previous video I just given an algorithm for that all pair shortest path. Now let us take one example. So here this is an example given a weighted direction graph. So this is the directed graph of G vertex of graph G, vertex V and E or edges with weight. So we have to determine the length of shortest path between all pairs of vertices in G. So here different three vertices are there. We have to find the length of shortest path between all pairs of vertices. Here we assume that there are no cycles with zeros or negative cost. So we have to assume there are no cycles with zeros and negative cost. So there is no negative values and no zero cost. Okay. So here we have to, for this vertex, what is the cost? If you start from this vertex, what is the length of shortest path of all pairs of vertices? If you start with this vertex, what is the cost? And if you start with this vertex, what is the cost? We have to find out. So the cost of adjacency matrix is already given. So this is the cost of adjacency matrix. So this graph is expressed in the form of matrices. How? So A of 1, 1. So if you visit 1, 1 is always 0. The cost of visiting the same vertex is 0. And 1, 2. So this is 1, 2, 3, 1, 2, 3. Cost of 1 of 2. 1 to 2, the cost is 4. And 1 to 3. 1 to 3, the cost is 11. In the same way, 2 of 1. 2 to 1, the cost is 6. And the cost of visiting 2 to is 0. And the cost of visiting 2 to 3 is 2. In the same way, the cost of visiting 3 to 1. 3 to 1, the cost is 3. And 3 to 2, there is no direction. So you can't go directly from 3 to 2. You have to go from like this. So you don't know what is the exact path. So just write infinity. And 3 to 3, the cost is 0. So this is the cost of adjacent matrix. So with the help of the adjacent matrix, we have to find out the next adjacent matrix. So here this is the general formula that already I explained in the previous video. So a power k minus 1 I comma k plus a power k minus 1 I k comma j. Ik, kj and c of ij. From these two we have to find the minimum value. So let us solve problem for different values of k, 1, 2, 3. So here there are three vertices. So just take the values of k as 1, 2, 3 and we have to solve the problem with the help of this adjacent matrix. Now let us start. So the step 1. So first solve the equation. So whatever the equation they are given, solve the equation for k is equal to 1. So what is the equation? Again I am writing the equation, that is we have to find the minimum value a power k minus 1 I comma k plus a power k minus 1 k comma j from these two and c comma I of j. So we have to find the minimum value. Let us start. The matrices you have to calculate first a of 1 comma 2, 1 comma 1. So a0 is already we know. Now we are finding the new path. So a0 we already find, that is the graph. So the cost of this graph is already fine. So now let us take a1. a1 comma 1. So 1, 2, 3, 1, 2, 3. A of 1 comma 1, just apply the formula minimum of. So this is I, j and k is 1 here. So this is the k value. K is 1, I, j. So 1 minus 1, a of 0, 1 comma, k is 1 plus a naught. 1 minus 1, 0 and the k is 1 and j is 1. Okay. And c of I comma j is 1 comma 1. Now write the values. What is the a naught of 1 comma 1? So with the help of this adjacent matrix we have to write the find. A naught of 1 comma 1 is 0. 1 to 1 is 0. A naught of 1 to 1 is 0. Comma c of 1 comma 1. So 1 to 1 the path is always 0. That is the minimum of is the value is 0. So first I got here the 0. Next I want to find a1 of 1 comma 2 means this value. So this value I have to be find out. Minimum of, what is the value? A0, I is 1, K is 1 plus A0, K is 1 and J is 2, comma C of I comma J. I comma J means 1 comma 2. Now find minimum of A0 1 comma 1 is 0. A0 of 1 of 2. 1 comma 2 is 4. First row and second column. A0 of 1 comma 4 is 1 comma 2 is 4. And C of 1 comma 2. C 1 to 2 the cost is 4. So minimum of 4 comma 4 is 4. Next. So this is 4 I got. Now A1 of 1 comma 3 I have to be find out. Again minimum of A0 of I comma K. I is 1 and K is 1. A0 of K is 1 and J is 3. C of I is 1 and J is 3. Now write A0 of 1 comma 1. 1 of 1 is 0. 1 of 3 11. C of 1 comma 3. C of 1 comma 3 is 1 of 3 is 11. The cost of 1 to 3 is 11. So the minimum value 11 comma 11, the minimum is 11. So A1 is over. Now I have to find out A1 of 2 comma 1. So this is A1 matrix. Now I am finding. Means I have to check whether which vertex, if I take, the cost becomes less. A1 of 2 comma 1. Just apply the formula. Minimum of A0 of 2 comma 1 plus A0 of 1 comma 1 comma C of 2 comma 1. So, minimum of A0 of 2 1. What is that? A of 2 1 is 6. So just write 6 plus 1 1 is 0. C of 2 comma 1. 2 to 1 is 6. So the minimum value of 6 comma 6 is 6. So A dash of 2 comma 2 you have to take. So always if you visit the same vertex, the value should be 0. A dash of 2 comma 3. Minimum of A0 of 2 comma 1 plus A0 of 1 comma 3 comma C comma 2 comma 3 I comma J. So minimum of A0 of 2 of 1. What is A of 2 not of 1? 6. 1 to 3. 1 to 3 is 11. C of 2 to 3 cost. 2 to 3 cost is 2. So from this, minimum of 17 comma 2, the minimum value is 2. Okay, so now we got 602. So just write that value in A1, 602. Okay, now I have to find out the third row and third row. A1 of 3 comma 1. So just apply the same formula. AK minus 1, that is 3 comma 1 plus A0 of 1 comma 1 comma C of I comma J. Now write minimum. What is that? A0 of 3 1. 3 1 is 3 plus 1 of 1 means always 0. C of 3 1. 3 1 is 3. So what is the minimum value of 3 comma 3 is always 3. Okay. So in the same way, next A1 of so let me take next A1 of 3 comma 2. That is the minimum of A0 of 3 comma 1 plus A0 of 1 comma 2 means KJ comma C of IJ is 3 comma 2. So now write a naught of 3 comma 1 is 3. Now check 1 2. What is 1 2? A naught of 1 2 is 4. 3 plus 4. Okay, and 3 to 2. What is the cost of 3 to 2? There is no cost. Okay, there is no backward. Only this direction is not there. So you have to write infinity. So from this the value is 7. So a dash of 3 comma 3 is always the cost is 0. If you visit the same vertex again, the cost is 0. Okay, so now what's the value here? Just you write that value here. 370. 370. So A0 matrix we get, A1 matrix we get. Now I will write the A2 matrix. Now find out the A2 matrix. There is a step 2. Step 2. So I am just taking the k values 3 up to. So solving the problem, let me write the equation. For k is equal to 2, I have to take the value of k is equal to 2. So apply the same problem, whatever equation. Now the k is 2. Previously I have taken 1. Now the k is 2. I comma j. First I have to start with 1, 2, 3, 1, 1, 1, 2, 3. So start with a of 1 comma 1. I have to find out for A2 matrix. I have to find out these values. So apply the formula. Minimum of a dash of 1 comma 2 plus a dash means k minus 1. 2 minus 1 means 1. 2 minus 1 is 1. 2 comma 1. C of 1 comma 1. So that is the minimum of a dash of 1 2. Now check the previous whatever the adjacent vertex. So now I take the A1. Instead of taking A0, I will take the reference as A1 vertex. A1 matrices. So A1 of 1 of 2 is 4. 4 and A1 of 2 1 is 6, comma 0. So the 0 is the minimum value. Next A2 of 1 comma 2. Just apply the formula. Minimum of A1 of 1 comma 2 plus A1 of 2 comma 2, comma C of 1 comma 2. So what is the cost of 1 of 2? That is a 4. And 2 of 2 is 0. And cost of 1 2 is 4. So minimum value is 4. A2 of 1 of 3. So just apply the formula. A1 of 1 comma 2 plus A1 of 2 comma 3, comma C of ij 2 comma 3. So the cost 4 plus, what is the cost of 2 3? So the cost of 2 3 is 2. 4 plus 2, comma, and cost of this is 1 3. ij 1 3. The cost of 1 2 3 is 11. So 6. So the matrix we got here is 0 4 6. So in the same way find out A2 of 2 comma 1. So next second row we have to be find out 2 comma 1. So we'll get minimum of A dash of 2 comma 2 plus A dash of 2 comma 1, comma C of 2 comma 1. So the minimum of 0 plus 6 comma 6. So here we'll get the 6. And A2 of 2 comma 2 means if you visit the same vertex you will get the 0 anyhow. And A2 of 2 comma 3, the second row and the third column, that is minimum of A1 of, that is 2 comma 2 plus A1 of 2 comma 3, C of 2 comma 3. So the value for this is, you will get minimum of 2 comma 2. So that is a 2. So what is the values for his second row? 6 0 2. 6 0 2. So in same way we have to find out A2 of third row. We have to find the third row. A2 of 3 comma 1. That is the minimum of A dash of 3 comma 2 plus a dash of 2 comma 1, 3 comma 1. From this we'll get 7 plus 6, the 3 a dash of 3 2 by checking the previous a1. 3 of 2 is 7, 3 of 2, third row and second column the value is 7, so just write the 7, and a of 2 of 1, 2 of 1 is 6 here, so 7 plus 6 comma the cost of visiting 3 of 1 is 3 comma 1 is 3, so from this the minimum value is 3. In the same way, a2 of 3 comma third row second column, minimum of a dash of 3 comma 2 plus a dash of 2 comma 1, cost of C of 3 comma 2, this is 2 comma 2, so we'll get minimum of 7 plus 0 comma 7, so the minimum value is 7. So for like this, the same a2 of 3 means 3 comma 3 is 0, the cost of visiting the same vertex is a 0. Now the matrix is 3 7 0, 3 7 0. So in the same way, for the value of k, that is the value of k is equal to 3. Similarly, in the step 3, solving the equation for k is equal to 3, you will get a3 is equal to 0 4 6 5 0 2 and 3 7 0. Okay. So these are all sequence of decisions. So whatever the A1, A2, A3, these are all the sequence of decisions. Let me write. These are all sequence of decisions and all final shortest path between all pair of vertices. All pair of vertices. Okay, so these are all the different decisions that are taken by the different vertices. So with the help of that, we can find out the shortest path, so which is having the shortest path, that we can select it. So this is about the all pair shortest path algorithm. Thank you.